Okay, so this week we're going to talk about creating instances of objects and then manipulating these instances by calling methods on them and getting them what you need to do. So this is kind of building off last week. So last week, if you guys remember, we talked about defining and declaring objects. So this is basically writing classes, right? So we all wrote our first class in lab last week. It was the ball class. So it modeled the ball, it had some different traits, and it had some different methods. Come on. There we go. So this was basically a mold. So what a class is it's a mold. It's like, let's say you have a mold for a hockey puck, right? Well, you don't actually have any hockey pucks. You have a mold. You have the ability to create hockey pucks, but you don't actually physically have any hockey pucks until you use the mold to create hockey pucks. So that's what we did. We created a mold for a ball. And now we're going to learn how to create instances of a ball. So actual balls that we can use. And this is something that was kind of done in the support code that you guys used last week for lab that you may or may not have realized, but now we're going to figure out how to do it for ourselves. So here's a little bit of a review. This is a simplification of the class you guys wrote last week in lab. So let's go through it a little bit real quick just because maybe we forgot exactly what some of these things we're doing. And so right up here, public class ball open curly brace, which corresponds to this closing curly brace down here. That's our class declaration, right? So basically here we're saying, Java, we want a new class, and we want it to be called ball. So that's all that is. And anything that lies in between this closing curly brace down here and this opening curly brace up here is a part of that class. It's the class definition. Now, what the class definition is kind of a collection of a few things. Does anyone remember what these three things up here are called? Anyone remember? There's a name for them. Those are the. All right, close. That's something else, but that's actually this down here. But these are instance variables, right? Does anyone remember that? So what our instance variables do is they model properties of our class. So this is the properties of our ball. Our ball has a size, our ball has a color, and our ball has a bounciness. And does anyone remember what makes instance variables special? What makes them different from local variables that we were writing in the first lab? Yeah, so that's actually one of the things that we use to distinguish them from local variables, and that is a good point. But what's something that makes it inherently different? Does anyone remember? All right, so what it is that you're able to access these variables throughout the whole class. So the first variables that we were writing were called local variables. And these lived and died within the method that they were created in. So if you create a local variable in a method, you couldn't access it in a different method. But the special thing about these instance variables is that you can access them anywhere inside the class. They live for the whole life of the class, which is really good. Because now we can have properties that aren't specific to a given method, they're specific to the class, right? Okay, and also these all have the private keyword. And that's because you don't want any other objects messing with your properties, right? And so those are instance variables up here. That's the first part of any class. And does anyone remember what this right here, this method is? It's kind of a special method. This is our constructor, right? So we all wrote a constructor similar to this in lab. And does anyone remember what's special about the constructor? It's got a few things. So it's always going to have the same name exactly, capitalization and everything, as the name of the class, right? That's just one of the rules. It's also not going to have a return type, as you can see by the absence of a return type in between public and ball. And last but not least, it's the method that's called when a new instance of your class is created. So this is what we're going to be doing today, creating new instances. And when we do, this is what's going to be called. This is what's going to execute. All right? And does anyone remember why we have these parameters in our constructor? This is because we want to be able to create different balls, right? Different instances of a ball. We don't want all our balls to be the exact same size, or the exact same color, or the exact same bounciness. So we give the constructor these parameters that allow us to create all different types of balls, right? So here we are setting our instance variables to the value of the input, to the value of the parameters, so that the size of the ball will be whatever the size of the input is. So that's good. That's constructors. So every class is going to have a constructor. And in the constructor, you want to set up your instance variables and do any other setup that you need to do when a new instance is created. And so here we go. This is what Matt was talking about. This is an accessor method down here, right? So this is our first method other than the constructor method, and what it does is it returns one of the instance variables. It returns the size in this instance. So this is really helpful because if you have something that needs to know what the size of your object is, but it can't see the instance variable itself, it simply calls this accessor method, getSize, on the object, and then it will use the return value as the size. So this is what the support code was doing in the lab last week. It was using these accessor methods to get the size of all the balls that you created when you were clicking and dragging around the screen, and then it would get those sizes and use them to display the proper size to the screen. And you may realize that this is omitting a few methods here, like the accessor methods for color and bounciness, and also there was a bunch of other instance variables and stuff. This is, like I said, this is a simplified version of the class that you wrote in lab, just so you could kind of see it a little bigger and it wasn't so cluttered. But basically, you can write as many methods as you want, and if you remember in lab, you wrote a lot more than just this single accessor method. So that's the review. This is declaring a new class and defining a new class, right? So does anyone have any questions on class declaration and class definition? I know there's a lot of stuff going on with it, and it is, again, one of the really important and special things about Java, but this is basically the basics of it. This is what you need to know to get going. Yeah.
Is there a reason why there's like no name?
Yeah, okay, yeah. So I'm going to repeat the questions because I haven't been doing that for the webcast or whatever. So Matt's asking, is there a reason that there's no main method in this class? And that's a really good question. So if you remember from other lectures, every program needs a main method, right? Because this is where that program is going to start, inside the main method. So we're assuming here that the main method is going to be in some other class that eventually creates the balls and like creates new instances of the balls and calls different methods on them. So it doesn't actually need to be, and there doesn't need to be a main method in every single class. There just needs to be one in the program. So this is what we're going to see later today, actually, when we start using multiple classes. So that's a really good question. Any other questions? All right. So that's good. That's a big part of getting objects going in Java. But the second part is creating instances of the class. So like I said, that was our mold. But it wasn't an actual instance. It wasn't something that we can use. It was just defining how the instances would act when they were created. So now we have to actually create them. And this is how you do it. And it's actually a lot simpler than writing the class. So after you've written the class, you can go ahead and declare a new variable of type whatever your class name was. So this should look pretty familiar to you. This is just like declaring a new int or a new string or a new double or any of the primitive data types, except for instead of using one of those primitive data types, you're using the class that you've just written as a type, right? So this is a new variable named myBall of type ball. And ball is something that you've written. So this is kind of the first variable of a type that you've written. It's not a primitive data type. Does everyone see where we're at so far? And then what we need to do, if you remember, this isn't actually giving it a value that we can use. This is just declaring it. Just like when you say int x. X doesn't actually have an integer value yet. It's just available to be used. So just like how you have to then define the integer variables, you have to define this ball variable. So this is how you do it. And the syntax is a little bit new, but it's pretty simple, so I think we'll be able to get it. So we're saying my ball, the new variable named my ball, gets, right, because we read equal signs as gets in Java, a new instance of the ball class. And then we're giving it these parameters, these inputs here. So these are the specific inputs for our new instance. Now, can anyone see what's going on here? Where are these inputs going to end up being interpreted by our ball class? Yep. Right, right. So do you remember where the bounciness size and the color were interpreted initially? Yeah, and the parameters for which method? The constructor, right? Yeah, so the first method. So if you go back real quick, right up here, right? Here's our constructor method. So when you say new ball, and then you give it these parameters, you're really essentially calling this constructor method. And you're giving it those parameters that we've defined right here. So size, color, bounciness. So let's look at it again. So here's our actual size that this ball is going to have, our actual color, and our actual bounciness. So this is saying, give my ball, variable my ball, a new instance of the ball class with these parameters. So these parameters go right into the constructor method, and that constructor method will then set the value of that class's instance variables to these parameters. So you guys kind of see how that works? So that's it. Now my ball is a usable instance of your ball class, and it's got some values for its instance variables, and it's basically ready to rock. And this new word right here, this is a new keyword. So remember last time we talked about keywords? They were the words that are native to Java, native to the language that is Java. And so this is a new one, and we're going to keep kind of learning some new ones as we go. But new, just like that, just like you see it right there. And if you type that into Eclipse, it's going to change colors, do the whole syntax highlighting thing, and you'll say, okay, that's right. You got it right. So that's the idea. So now let's use this new instance to do some things that we want it to do. And by that, I mean, let's call some methods on our instance. So first, we're going to create a variable to hold the return value of this method. And so this is something we've seen before, just declaring a new variable of type int, name my ball size, right? And then now this is what's new. We're going to say my ball size gets my ball dot, period, whatever you want to say, get size. Here are our method, parentheses, semicolon to end the line. Okay, so what you need to know is the dot in Java is how you call a method on an instance. So our instance is my ball, right, which we created in the previous slide. And we put dot, so that means we're going to call a method on my ball, and the method name is getSize. So does anyone remember what getSize does? It returns the instance variable underscore size to whatever calls it. So my ball size gets the return value of this, which is underscore size of the ball. Is everyone kind of seeing how that works? Now this is really important. This is how you call methods on an instance, which is something that is really powerful. And it's how you get your methods that you've written to actually work and do something for you. Now, something that's really good about Eclipse is that when you put my ball here, or you put an instance down, and then you hit dot, a list of potential methods that you can call is going to pop up right next to it. And it's actually really good because sometimes you forget exactly how the methods are spelled and exactly which methods you can possibly call in an instance. So that's something that's really, really nice about Eclipse. It's one of the best things in my opinion. And so use that to your advantage. And so that's the idea. So can anyone know what the value of this variable is going to be after this gives it its return value? It was on the slide before. 60, there you go. Because that's the size of our ball instance, right? So that's pretty cool. Now we're getting a new variable in a different class, presumably, to talk to our variable of the class that we've defined last week. We're finally getting our pieces to kind of talk to each other. So this is really important, and this is the essence of object-oriented programming, and it's really what makes it all happen. And this probably seems really trivial right now, but when things start getting more complex, you're going to start seeing how beautiful this really is. Okay. So let's put it all together just so you can see the example fleshed out. Here it is. So we've got a new class, right? This is a class declaration up here. Public class main. So our class name is main. Our open brace up here, our closing brace down here. So everything inside of it's part of the class definition. And this is where we're getting to the answer of Matt's question. This is where our main method is going to lie, right? So this is where our program is going to kick off. Everyone recognizes this is the main method, right? Whenever you see public, static, void, main, string, args, that's your main method in Java. So here it is. This is our program. This is how it's going to run. We're declaring a new variable of type ball, which is a class that we've previously defined. Name myBall gets a new instance of the ball class with these parameters right here. Does everyone see that? So now down here, we're saying we got a new variable of type int, name size, gets myBall dot get size. So we're calling the get size method again on the myBall instance, and we're taking the return value and we're putting it in the new size variable. So does everyone see that? And then down here, this is something we're revisiting from the first lab, where system.out.println the size, so we're going to display the size to the console. So does anyone know what's going to be displayed to the console exactly? Yeah, so it's just going to say 50, right? So it's going to be an int 50. Does everyone see how that works? We've given our ball a size of 50 initially, and then we've asked the ball, okay, what's your size again? And it said, my size is 50. And then the system prints it out to the console, says 50. Yeah? Oh. Does this do away with it? Well, this is kind of like, okay, yeah, the question is, does this get rid of the slider that we had in lab last week? And basically, this is in lieu of the slider. So what your program did last week is it had like a much more complicated main method that dealt with the sliders and the buttons and the checkboxes and stuff like that. But it was the same idea. It was just calling get size on all the ball instances that were created, and it was using this. So the size was whatever the slider value was. So when your object was created, it said, okay, what's the value of the slider? Rather than just saying, okay, 50 right here, it said, slider.getValue. And then right here it said whatever if you remember the color button had a color picker or whatever when you hit it. So it would get the value from the color picker here, and then the bounciness was another slider, so it would get the value of the slider. So it was a little bit more complicated, but really it was just the same concept of creating balls, and instead of having it hard-coded in here like this where you just say 50, it was getting the value from the slider. Yeah?
So, where it says color.red, it happened to be
Okay, yeah. So you got us. The question is, why doesn't it say java.awt.color.red? The answer is it should. I just omitted it because I didn't want this to get too long, so I could still keep it big and have it be on one line. But there is actually a way so you don't have to type that every time. You can import libraries. And I'm going to show you how to do that in an upcoming week. And that makes it so you don't have to put out the whole path to the library every time. You can just address it more simply. But yeah, for now, this should say java.awt.color.red. It's just I just took a shortcut so it's easier to see.
So that red, right?
Yeah.
Is that a particular shade of something from that library?
Yeah, so that's so it's the library is an object, and red is one of the fields, the instance variables actually, and it's just going to be some representation of red. It'll just be one shade of red, and it has a bunch of different fields that could be basically any shade you want. But don't worry about that too much right now. Just think of this as the color red, and we're going to get into the specifics of that library and other libraries in upcoming lessons. But for now, just think of that as red.
And why is that capital?
The color dot red. Is that what you're asking about?
Red.
Oh, red. That's just how that's kind of a convention with fields, is that you make the names all caps. But yeah, it's just specific to the library. It's just how they wanted to do it, basically. But so that's the idea. So any other questions on this? So now we've kind of put it all together, which is really good. And we actually know a lot about objects. We know more than you may even think you know, because you know how to define them and declare them, and now you know how to create them and manipulate them, which is really, in one sense, all you need to know, but in another sense, you still have got some stuff to learn. But let's kind of abandon this ball example that you guys are probably all really tired of, and let's move on to something new. Let's create a gate and lock system. So it's going to be a system that models a gate and a system, and well, it's all one system, but a system that models the gate and it models a lock as well. So let's get on to it. But first, okay, we're going to learn about a different tool. So remember last week we talked about the flow of control. Now the flow of control is what describes the path that your program takes from start to finish. And up until now, this flow has just been one list of instructions. It won't change, it's just a start. You do this, you do this, you do this, and then you finish. But a lot of times you want your flow of control to be able to change based on maybe input from the user or some value of your variable. So how are we going to accomplish this? Well, we're going to accomplish it with if statements. So this is a whole new concept that we're learning right now, and it's really cool. And I'll give you an example of when you'd want to use an if statement in real life in English. So let's say you're giving directions to someone about how to drive to your house. Now, if they have a full tank of gas, then you'll just give them the quickest directions from how to get to their house to your house, right? But let's say they're low on gas. Then you're probably going to give them directions to the nearest gas station, and then from the nearest gas station to your house, right? So the condition is whether or not they have enough gas, and there's two possible executions of the program. It's either go straight to your house or go to a gas station first and then to your house, right? So that's kind of an example of when you want the flow of control to be able to change in your program. But before we get into the specifics of if statements, we have to do a little bit of a review on Booleans. So we didn't really touch too much on Booleans. I did tell you about them in the first lecture, and we did kind of touch them in the first lab, but they probably seem kind of dumb to you. They're basically a variable type which can have one of two values. They can either be true or they can be false. And this on its own probably seems like not very useful, right? I mean, it's just either true or false. It's not much. But when you start using them with these if statements that we're about to describe, they become very important. They are what drives the if statement. And just so you know, here's an example of declaration and definition. So it's just like any other variable declaration. We've got our type here, Boolean. We've got our name is locked. And then here's our definition, gets true. And true and false are actually Java keywords as well. So they're going to change color when you type them into Eclipse. And as is Boolean. So that's a little bit of a Boolean review. Does anyone have questions exactly on Booleans? Nothing? All right, cool. Yeah, they're pretty simple. So here are if statements. Like I said, these are going to help us modify the flow of control of our program based on a condition that we set. So here's the idea in English. there it is. If the gate is closed, then open the gate. Right? Simple. Our condition is whether or not the gate is closed. If it is, open the gate up. We say this stuff all the time in English, so it's pretty simple. Now, here's the idea in Java. So we've got some new syntax here and some new stuff going on, but it's pretty intuitive, so let's just go through it. We've got the word if, which what do you know is another keyword that we're learning. Then we've got our open parentheses, our closed parentheses, and right here is our condition. So this is our Boolean value. This, which you may recognize, is a method called on an instance of a gate class, is going to return a Boolean value. So it's either going to be true or false. The gate is either closed or it's not. So if the gate is closed, this will be true. If the gate is false, if the gate is open, then it'll be false. And then, so that's our condition. And then here is our block of code, gate.open. So if this condition is true, then execute this block of code. So if the gate's closed, then open it, right? Just like it says up here in English. Does everyone kind of see the idea there? We're going to get into the specifics of the syntax right now. So, like I said, we've got our new keyword, if. We've got our parentheses, which encompass our condition, which is always going to be a Boolean value, either true or false, right? And then we've got our open curly brace here and our closed curly brace here, which bookends the code which we're going to execute if this value is true. Does everyone see what's going on there? It's not too complicated, but it is new. So if this value is true, then this code will execute, and if this value is false, then it's just going to skip right over whatever is in between these curly braces and just move on right down here underneath it. So if it's false, then it just doesn't even execute. It's like it's not even there. You guys see that? Okay, so this is good. But what if we want to execute something different if this is false? What if we want to do something totally different? Well, there's a tool for that too. Oh, yeah, and the curly braces, which we saw. So the tool is the else block. So here's how it works. The else block executes if the if condition is false. So if gate is closed, gate open. Else, gate closed. So can anyone see what these lines of code are going to do? If the gate is open, yeah, go ahead, Dan. Yeah, okay. So how about, okay, so what about if the gate's closed? Right. So how it's going to work is this is how the program is going to read. It's going to say, if the gate is closed, so if this is true, open it up. And then skip this and keep on going on. Keep on executing the rest of your program. And then in a different scenario, if the gate is open, right, it skips this block, this top block, heads down to the else block, and performs this. So it'll close it. So basically, in this scenario, if the gate's closed, it's going to open it, and if the gate's open, it'll close it. Do you guys see how that works?
So the default thing is it's true?
Yeah. So this is what happens if the condition here is true, and this is what happens if the condition here is false. Yeah, so it takes a lot and puts it into not very much, but it is actually pretty intuitive once you get the hang of it. But we're going to add an extra bit of complexity right here. So what if there's more than two scenarios? What if it's more than, if this is true, do this, if it's false, do this? Well, there's a tool for that too, and it's called the else if. So here's an example of when you'd want to use that. So here we're saying if time is less than 12, so we're going to assume we're on military time here, whatever, where you can go 0 to 24. Display good morning. Okay, so if it's earlier than 12, print good morning. And then here we are, else if time is less than 19 or it's earlier than 7 p.m., print out good afternoon. Okay? So this else if is a second condition. So if this first one's false, the program comes down here and says, okay, what about this condition? Is this true? And if it is, it performs this. And then we have our final else block. So if this was false and then this was false, we fall back down to our else block and this happens. Yeah. What do you say?
If you have 4 or 5, do you just do a bunch of else ifs?
Yeah, okay, yeah. So if you have, like maybe you have 20 different conditions you want to test here, you just do if the first one, then else if the second one, else if, and then a bunch, and you can end on your catch-all, which is your else. So you can have as many else ifs as you want, but you really have to pay attention to the order because the order is important, right? Because let's say you put this first, time is less than 19, if time is less than 19, and then down here is else if time is less than 12. Well, that would never happen, right? Because if time is less than 19, then it's also necessarily less than 12. So it would never actually perform the second one. So you have to pay attention to the order of your statements. But yes, you can have as many else's as you want. Joe? Well, this is actually not like exactly how you get the time. Like you don't just say time. Like we're assuming that there's a variable up here that's called time that was set to the time. But yeah, usually how you do it is you call a library function which represents the time, and I think it is usually in military time. But we'll get into that later when we get into more libraries and stuff like that. But that's the idea. So is everyone kind of comfortable now with else if? I know this is a lot coming at once, but this is like our if statement section. All right, so that's good. So now we got to get into a little bit of Boolean arithmetic. So let's see. This is really important, and sometimes we want to make these comparisons like we made up here, right? This less than comparison. So we took presumably an integer and compared it to another integer. And that comparison created a Boolean value. So if the time was less than 12, this value would be true. If the time was greater than 12, this value would be false, right? So we used our comparison to create a Boolean value. So here are a list of the comparisons we can do. First one is equal to. And I don't know if you can see very well from where you're sitting, but this is actually 2 equal signs. And so, of course, this is pretty unintuitive, right? But if you remember, we're already using the single equal sign to assign value, right? So this is kind of where this is affixed to be able to have that mean something and have equal mean a different thing. And it's really unintuitive, and it's kind of unfortunate that it's like this, because I guarantee you that if you keep writing Java, at some point you're going to write a bug that is you using 1 equal sign instead of 2 to compare 2 things. And I've done it many times, and it's really hard to find, and it's really annoying, but this is just something you've got to kind of hammer into yourself. It's just 2 equal signs means equal to. And then we've got our exclamation point and then equal sign, and this is not equal to. So the exclamation point basically means not in Java. And then greater than is pretty straightforward. This is just like math. Greater than or equal to is pretty straightforward. Again, it's just the greater than sign and then an equal sign. Less than, pretty simple. And then I'm sure you would guess less than or equal to is the same thing as it actually is. And so those are our comparisons. And this is what we can use to compare 2 ints or 2 doubles and use that to create a Boolean value. So what is the value of this comparison right here? 5 less than or equal to 3. False, right? Everyone see that? Pretty simple. But now here it is. Here's our Boolean value. 5 less than or equal to 3 is the Boolean value of false. Does everyone see that? Not too complicated. And so here we go. Here's some more stuff. So sometimes you're going to want to test more than one condition. So maybe you want to say, when you're giving your directions to your friend, if you're not out of gas and you have the time to come to my house, then go this way, right? So that's an and, right? And this is how you do and in Java. It's 2 ampersands. And again, this is kind of unintuitive. You probably think it should just be one ampersand, but that actually means something else that you probably won't use very much because it's kind of like outdated. But so 2 ampersands is and. And then these 2 straight up and down lines, which I'm not even sure what the correct name for those characters is, means or. So those are our comparisons. So knowing that, does anyone know what the Boolean value of this statement is going to be? Okay, so it's false because, so what's the value of this first condition here? 5 not equal to 3. That's true, right? 5 is not equal to 3. And then what's the value of the second condition? 7 less than 7. That's false, right? And with an and, it requires all the conditions to be true. So this is, of course, false. Does everyone see that? And then what about this? What's the value of this statement? True or false? Which one do you think? True? True, right? Did you guys see? It's just like math in English. So we've got 5 not equal to 3, right? We've already decided that's true, right? Just the same as up here. Then we got 7 less than 7. We've already decided that's false. But the nice thing about, or not necessarily a nice thing, but the thing about or is that you only need one condition to be true in order for or to be true, right? If you say, do you have enough gas or do you have enough time, and they have enough time but they don't have enough gas, that's still a yes, right? That's still true. So this is the difference between or and essentially. Or only requires one condition to be true for the whole statement to be true, and requires all conditions to be true for the statement to be true. Do you guys see the distinction there? Okay.
So the or, is that somewhere on the keyboard?
Yeah, that's right above enter. If you have to hit shift and it's like the backslash otherwise. Yeah, it's kind of a weird one. You don't really use it in any other situation, but that's what they came up with. That's what the makers of Java came up with, and so that's what you have to do. So that's Boolean arithmetic. It's really useful. Understanding it is important. So let's do a little review here. So we're declaring and defining 3 variables up here. So we've got an int x, which gets the value of 5, int y gets the value of 6, and we've got a Boolean with the name bool, and it gets the value of true. Okay? So now let's evaluate some statements. So what's the value of this? Yeah, so it's false, right? So this is saying x equals y. Well, that's false, right? Because x is 5 and y is 6. So that's false. Does everyone see that? So what's the value of this? X less than or equal to y. True. Right? It's just simple stuff here. 5 is less than or equal to 6. So we've got a true. And what's the value of this? False. Does everyone see that? Y is less than or equal to... Wait, yeah, this is...
True, yeah, but you can eat it.
Yeah, sorry, that's true. Yeah, I got messed up. That is true. Why is this true? Y is less than or equal to x.
Because
Is that true or false? Right over here. That's false. And then what's this? Or x is less than or equal to y. So that's true. My mistake there. Nice catch. Okay. And what about this? False. Does everyone see why? We got exclamation point bool. An exclamation point, like I said earlier, means not in Java. So it's not true. It's not true. It's false.
but then you have to be an exclamation point like an equal sign.
Yeah, so I didn't actually tell you guys this exact usage, but you can just do exclamation point and then a Boolean value, and it knots that value. So if it's false, then it's true. If it's true, then it's false.
Okay.
So that's the idea with the exclamation point. And then for the closer here, we got something a little bit more complicated. What's the value of this statement? True? Does everyone think true? Because we got bool, which is true, and x not equal to y. That's true, right? 5 is not equal to 6. Then we've got x less than 10, which is true. So all those are true. True and true and true is true, right? It's pretty intuitive. So that's the idea. Any questions on Booleans and Boolean arithmetic and combining Boolean statements and all that good stuff? If you got a good handle on that, then that's really good, because there's a lot of instances when you want to check a bunch of different conditions and they can get pretty complicated pretty quickly. But now you guys have the tools to know how to do it, so it's good. And so here we are. We're back to our gate lock program. So let's talk about the design real quick. We're going to have 3 classes. We're going to have a gate class, which models a gate. We're going to have a lock class, which models a lock. And then we're going to have a main class, which has a main method, which is going to kick our whole program off, right? So this is actually one of the things that's really, really nice about object-oriented programming, is that your programs tend to almost design themselves, because you're using objects to model real-world objects. So it's pretty obvious that if you want a gate lock program, then you're going to want a gate, you're going to want a lock. It sounds trivial when you say it like that, but when you get more complex programs that have hundreds of objects, then it's really nice that you can just kind of revert to the real world to be able to design your program. And that's kind of one of the principles of object-oriented programming, which Java promotes. So basically, the goal of our program is to model the functions of a gate and a lock. And these are 2 things that are used for security, and each one on their own is not very good. But once you combine the 2, it's a pretty effective security mechanism, right? And so this is what we're looking for. How do we combine the 2 to create our desired program? This is something we haven't done yet. So let's just get into it. Here's our lock class. So this is a lot at once, but we can understand it all now, so let's just break it down. We've got our class declaration up here, right? Public class lock, open brace, close brace. Then right in here we've got our class definition. So right up here, remember, is our instance variables, right? Does everyone see that? So these are the properties, again, of our lock. So it's going to have a code, like a combination, which is an integer. And it's going to have a Boolean variable is locked. So this is the state of the lock. Is it locked or is it not? Right? Is locked? If is locked is true, then it's locked. If is lock is false, then it's not locked. It's unlocked. And then right here, what's this method? Anyone remember the name? Constructor, right? Constructor, there it is. So this takes in a code. So this allows us to create different lock instances that have different combinations or different codes. It sets the parameter code here or it sets our instance variable rather to the code which comes in as a parameter. And then it sets our is locked to true. So our lock's going to start out locked, right? Just like when you buy them in the store. And then we've got 3 more methods down here. So can anyone see what this method's doing? It's basically locking our lock, right? It's setting is locked to true. So when is locked's true, our lock is considered locked. And so it's got no return value and its name is lock. And it's got no parameters either. It's a really simple method and it's effective, so it's good. And then can anyone see what this lock is, or this method's doing rather? Unlocking it, right? Or it's not necessarily unlocking, it's unlocking on a condition, right? So this is our first if statement in practice. So what's this saying? If the code that comes in as a parameter equals the code of the lock, our instance variable here, then go ahead and unlock it, right? So this is our point of security right here. So if you try to unlock it with a code that isn't the same as your instance variable, then it's just going to say it's not going to do anything, right? It's just going to skip this code and the method's not going to do anything. So that's our point of security. basically, if you try to unlock it with the incorrect code, the lock's still going to be locked. So that's the idea. So that's a pretty nice method. It's our first if statement, and it's pretty simple still, but it gets something really cool done. So that's nice. And then what's this method down here? Yeah, so it's just, right, exactly. It's an accessor method, and it enables someone to ask the lock, are you locked or not? Right? It asks is locked is the name of it, and it returns the variable is locked. And if that returns a true, then you know that the lock is locked. If that returns false, then you know the lock is unlocked, right? So that's the whole class right there. It's got some instance variables, a constructor, and then 3 other methods. Nothing too complicated, but this is our first usage of if statements, and it's definitely starting to do some stuff that's a little bit more clever than we've already dealt with. So that's good, right? Oh yeah, I forgot to do all that stuff, but we talked about it, right? Instance variables up there, constructor there, and our other methods here. Okay, so that's good. What about our gate? Yeah, sorry.
What's the difference between on the last slide? What's the difference between the first one and the last one? Not the first one.
Oh, the constructor?
Yeah.
And these other methods? Yeah, so they all...
And the bottom one.
Oh, which one? This one?
Yeah, and the bottom one.
And this one? Okay, so this first one's our constructor. The question is, what's the difference between this constructor method, the first method, and the last method, is locked. So the constructor method is getting called when we create a new instance, right? So it's only called once, and it's called when you use that new keyword and you assign a new instance to a variable. And all it does is it just sets up your instance variables, right? So it gives our instance variable the code that we want, the initial code, and it gives our isLocked instance variable the value of true. So this is just used once off the bat when a new instance is created. Now this last method down here, isLocked, is doing something completely different actually. It's just returning the value of the isLocked instance variable. So this will be used whenever you want to query the lock, or to ask the lock whether or not it's locked. So that's just but they are both methods, and they're both kind of talking to the same instance variable, but they have a different purpose. So that's the idea. Okay. Are any other questions on the lock class actually? No? Okay. So here's our gate class. So it's got a pretty similar structure, and again, let's just go through it. So we've got a declaration again, just to be thorough, public class gate, open curly brace, closing curly brace down here. Everything in the middle is part of our class definition, right? We've seen this before. And then what do we have up here? What are these two things? Instance variables, right? Just like before. So the first thing in your class is typically the instance variables, and it's the declaration up here. You can see that we've got our underscores, we've got our private keyword, and we've got our types. Now this is kind of cool. This is the first time we've used an instance variable, which is a type that we've already defined. So this is a version of our lock that we just defined in the slide prior, right? And so we've also got a Boolean is open, and that's kind of similar to the is locked Boolean, right? For the lock class, it's basically going to let us know, is the gate open or is the gate closed? It holds the property. It holds the state of the gate. And so what's this? Constructor, right? You guys starting to see that? It's got the same name as the name of the class, and it's doing some setup here. So it's setting our lock to the lock that you hand in as a parameter. So this is going to be an instance of the lock. And so our instance variable is set to this instance of the lock. Does everyone see that? And then right here, our door starts out closed because is open gets false when the instance is created. And then we've got 3 more methods. So what's this one doing? It says it's kind of cheating because there's comments right here that kind of describe it, but what's it?
Well, I think we put up there is closed, you need to say true. Would you?
What are you saying? So you would say if...
No, so like you start up top in private Boolean, and you just do is closed, and then down the next one you could do is
Yeah, that's totally fine. You can do it like that if you want. I mean, it's your program, so you can. That's totally fine. I just decided to make it is open, but it'll basically be the same thing because is open will be false when is closed is true. But that's totally fine, and it's good that you're thinking about different ways to do it. So okay, back to this though. What is this open method doing? It's asking our lock, right, our lock instance, if it's locked. So then also you can see this nifty exclamation point here in the condition of the if statement, right? So that's saying if the lock is not locked, right? So if it's unlocked essentially, then go ahead and open up the door, right? So here's our second point of security. So we're using our lock and we're saying, lock, are you locked? And if it says, yeah, I'm locked, then this is going to be a true, and this is going to not the true, so this is going to be false, right? So what happens when the condition of an if statement's false? You skip over the block of code, right? So if this is locked, then this will be a false Boolean value, and then we'll totally skip over this, and nothing will happen, the door will remain closed, right? So that's another point of security. Does everyone kind of see how that works? We're using our lock, asking if it's locked. If it is locked, we're not opening anything up. If it isn't locked, then this not false will be true, and then we'll go ahead and open up the door. Does everyone see that? So this is really similar to the unlock method, or it might have been, yeah, unlock method in the lock class. It's using the same principles, but we're using the lock that we already have. So that's a pretty cool method. And then what are these ones doing down here, these two methods? What's close doing? Does anyone see? Pretty simple, right? It's just setting our is open to false. So now our door is, in a sense, closed because it's no longer open. The state of our lock, or the state of our door rather, is open is going to be false. So it's basically closed. Does everyone see that? And then this, yeah, so this is open method is another one of those accessor methods, and it just returns the is open. So anyone that calls this will basically be able to see whether or not the gate is open. Or yeah, I've been saying door, but I guess I mean gate, sorry. It doesn't really matter, it's the same idea. So does everyone see how that works? So those are our two methods, or not our two methods, our two classes. Now we've got to get them in a main method, right? Oh, damn, keep on forgetting this, but yeah, there it is. So here's our main class. So this is going to house our main method, right? Here it is. So again, class declaration up here, open curly brace, close curly brace. Then what's this? Main method, right? Public static void main, that's our main method. So this is what's going to kick off our Java program. It's got this open curly brace, this closed curly brace, so this whole thing is our main method. So what's this first line do? And well, it says it right here, right? So it's declaring a new variable of type lock, name myLock. It's giving it the value of a new instance of the lock, right? And the code that we're setting for it is 1, 2, 3, 4. I don't know why I said 1, 2, 3, 4, 5 over here. It's 1, 2, 3, 4. Does everyone see that? So this is then in turn going to call the constructor of the lock class, and the instance variable that's underscore code is going to get this value 1, 2, 3, 4, and it's going to get the default is locked value of true, right? And then the second line, we've got a new variable named myGate of type gate, gets a new instance of the gate class, and we're giving it the lock that we've just created as a parameter here, as input, right? So that sets our underscore lock instance variable in the gate class to myLock, and it sets the default is open underscore is open instance variable in the gate class to false, right? So now we call mygate.open, so we're calling a method on our gate instance here, and then we're going to print out my system.out.println mygate.isOpen. So we're asking our mygate instance, is it open? So what's this going to return? What's this going to display to the console? Does anyone know? Well, it's going to display the return value of this, right? So is it going to be true or false? Can anyone see?
You are flooding your code.
So, okay, so I heard it true, right? This is kind of a trick question, or it's exactly a trick question. So we've called mygate.open, right?
Yeah.
So you might think that this would open our gate, right?
Asking it to open.
Yeah, so we called mygate.open in this line up here, and then down here we called mygate.isOpen, so a different method, which, if you remember from this slide, returns the value of isOpen. So isOpen is a Boolean, so it can either be true or false. So does anyone know, is the gate going to be open or closed here? Is this going to be true or false?
Does it depend on what you put in for the code?
Well, okay, yeah, that's basically the essence of the question. So we've tried to open the gate here, but is the gate going to open?
Is there a code in there? No.
Well, okay, so the gate.open is right here, right? So what it does, it asks its lock whether or not it's locked. And if it is locked, then it does nothing. It doesn't open the gate. The gate remains closed. But if the lock is unlocked, then it opens it up. So basically we have to decide whether or not our lock is locked or unlocked up here before we call mygate.open. Can anyone figure that out?
Calling it locked. You are at the beginning. Did you say it was locked?
Right, because in our constructor method of our lock, we have isLocked gets true, right? Does everyone see that? So the default state of the lock is locked because the constructor method makes it so. So unless you call unlock on the lock with the correct code, it's going to remain locked, right? So right here we've got a locked lock. We tried to open our gate, but we failed, right? Because the lock is locked. So system.out.println mygate is open is going to return false. Do people understand that? It's so this is like the culmination of the last couple slides. This is like the two classes working together to create our security system the way we want it to act, right? So we've got a locked lock. We didn't even try to unlock it, and then we tried to open our gate, but it didn't allow us to because the lock was locked, and our gate is still closed. So what if we change the main class? I know this is towards the end of the class, but let's just go through this really quickly. So we're doing the same thing here. We're creating a new instance of the lock, giving it to mylock. We're creating a new instance of the gate, giving it to mygate. Now, here we go. What's this doing? This line right here, mylock.unlock with the code. Yeah, so the code's the parameter, and unlock's the method getting called on the instance of mylock. What's that doing? Yeah, Dan. Yeah. So the code here is the same code we used to define the combination of the lock, right? Right in the constructor. Then we're using the same code. So what? Right. So this unlock method is going to successfully unlock the lock. And now we call mygate.open on an unlocked lock, right? So what's that going to do? Open up the gate, right? And then, so what's this going to print out then? Mygate.isOpen, true, right? You guys see that? And then right down here, what are we doing? We're locking our lock back up. We're closing our gate up. And then what is this going to print out? False. Do you guys see how that works? Now this is kind of like the culmination of a few things. We've written some methods, we've written some classes, we're making them work together. And because we used kind of appropriate method and class names, this reads pretty intuitively. So it's not too hard to understand. I know it's a lot of new stuff, but we're going to get it soon. Oh yeah, okay. And so we're starting to see how this more complex stuff works with multiple classes and classes using other classes that we've written. And so this is some good stuff. And basically, we're going to be writing a more intense version of that gate and lock system in lab on Wednesday. And this is going to be kind of like a turning point in the labs, because it's going to be a lot more of you guys writing your own stuff and less of the lab telling you exactly what to write. But that's the idea. So nice work today, guys. I think we went a little bit over, but that's really cool. So good job today, guys, and see you guys on Wednesday.